Okay, let's start slowly. Still come in as you like. Good morning, bonjour, and welcome to our talk on how we at BMW use the Zuul CI as our standard gating system. Very nice to be here. Thanks for having us, and yeah, let's dive directly into our topic. What you see here is a metric from our system, how we use it. And it does show the amount of CI jobs executions per 1 hour over the course of the day. So there are two things you can see here. One thing is there's quite some dynamic. I mean, we are European mainly based. There's development all over the world. And there's, of course, also releases and so on going on all the time. But there is also some main load, and our CI system has to cope with that, to give our developers timely feedback and to support integration speed. The other thing that you notice is it's 20,000 per hour, so that is quite a lot. That is what we have been scaling up the system today. It was quite some work, sometimes also some pain together and to overcome bottlenecks. And we share some of the things we have been doing there. But you might wonder, why do we need that amount of job executions, and why do we build up such a big CI system and scale this? So I want to, maybe most of you are not so familiar with automotive, I don't know, maybe some are, you all drive a car, and automotive development has been changing a lot the recent years. Let's look into a very new model. That's a BMW, we call it Neue Klasse, so it's a new generation of cars. Was just launched, so this will come to the customers next year. And you can see there's the traditional central display with a lot of information. There's a head-up display, and there's something also new, full panoramic iDrive, we call that, panoramic display. So there's a lot of information for the driver, also for passengers. And this information, of course, also is coming from the car, so the car is aware what the situation is and helps and assists the driver with many safety features and autonomous driving more and more. So if you think about it, it's quite some complexity that we have today in that car, and it's maybe one of the, if not the most consumer-based product that we build. And that means a lot of the software functions a lot of the customer functions are software-defined nowadays. We speak of the software-defined vehicle, therefore, in the automotive world. And it's clear that we have to support our developers there a lot to manage this complexity. One way is to have the right tools, and so that they can focus on their innovation and not so much on the tooling. Another thing is, this is also from this Neue Klasse. In the past, there have been more small and many small computers in the car, all connected. We call them electronic control units. And the trend is now to integrate more and more functionality into bigger such units, because also the functionality is overarching, and we need also more power here to do that. We call that even super brains in this Neue Klasse. There are 4 of them. And that means our developers need to work much more together and integrate a lot of changes every day together. Because so these projects are quite big, and it's not isolated anymore. And that's an area where Zuul is actually very powerful, and we have been choosing Zuul for many years now, and Zuul is helping there a lot. Yeah.
Also, good morning from my side. My name is Zhang. I'm a DevOps engineer in the CI project. I'm also an active contributor to the Zuul project. In BMW, we have a software factory platform that serves all the software projects. In this V module, you can see it is built from around 3 main platforms. that covers all the software development lifecycle. At the beginning, we have architecture craft that handles software requirement and architecture. At the end, we have validation craft that serves for validation and integration. In the middle is the code craft, which is our focus. It handles software development and the and quality. The software CodeCraft platform is not just one tool, but a full menu of services: source code management, Artifactory, logging, and more. It is built on a common infrastructure that is a hybrid of AWS and on-prem OpenStack cloud. And the CI/CD is one of the services. We use Zuul with customized libraries to fit our workflows. In case you are not familiar with Zuul, Zuul is a CI/CD system that focuses on project gating. And the main components are the Zuul scheduler, which handles event processing and job scheduling. It decides which pipeline to trigger and which jobs to run on the pipeline. And Node Builder is for building customized images. Node Launcher then launches the build nodes from the cloud. And finally, Zuul Executor runs the playbook against the build nodes. And the Zookeeper plays a central role here for communication among the components. You can consider it as a shared memory. And this is our current setup. At the core, we have Zuul Scheduler and Zookeeper deployed in a single region. And the Node Builder, Launcher, and the Zuul Executors are deployed across clouds and regions to minimize the cloud cross-region data traffic. All the components are deployed in a high scalability and reliability way. For example, currently we have 20 Zuul Scheduler instances and more than 100 Zuul Executor instances deployed. With this setup, it scales to serve more than 15,000 internal and external developers, delivers more than 210,000 daily builds currently, peaks at over 7,000 parallel builds that utilizing more than 100,000 vCPUs at the same time. We have been working for years to get there. Start small. We were among the early Zuul adopters, even before version 3, if you know Zuul. And I still remember the early days when users reported issues. Many of the answers were, it will be resolved in Zuul version 3. But that's already many years ago. Not only have we been benefited from the growth of Zuul, but we're also contributing back a lot back to the project. Let's share what the journey looks like.
Yeah, we want to show a bit what changes we have been contributing with and looking back, because by this you also see what was and is important for us and what we have done. And as Zhang said, it was quite a journey. Also now it was nice for us now looking a bit back. So in 2017, 18, that was actually around the time when we decided, okay, we want to go for a central CI service in our company and serve that to everyone. And that was when we adopted Zuul version 3, and we already spoke at about a large-scale CI system. So that's our colleague Toby, who was also an early adopter and a maintainer. He still is in Zuul. And he already mentioned, okay, key feature is having gating support with the speculative possibilities in Zuul, so that we really can get also speed in the integration. At that time, we did not know what we meant maybe with large scale, because if you look now back, yeah, we would not have imagined that we scale it up that much. Yeah, then the first big feature we have been doing, so I've been showing you a bit this connected things in automotive, a lot of ECUs, so these control units, and you need to work together. And unfortunately, a lot of our changes are sometimes you need to do them together and validate them together, integrate them together. So that's what our colleagues sometimes need. Zuul did already support dependencies, but directed dependencies very well. And what we did add here was that we did add support for circular dependencies so that developers can actually integrate and validate changes together. And that's even possible, across different source code systems, like if you would use GitHub and Gerrit together. It took quite some time to do that change, but finally we got that merged, and meanwhile, recent years actually was extended further to support Gerrit topic handling, to optimize also if there are same jobs would be executed and things like that. And led actually also to some corner cases. So in the end, we did actually also, together with Jim here, with Gating, a refactoring that also made this more solid, and meanwhile we really there are no problems, I would say. That's really very, very good. Then you have seen our current architecture, but actually there was a time when there was a very important component in Zuul, the scheduling, which was only a single component. So whenever we did updates, we had downtimes, and we had also really outages and stuff like that. And we said, okay, we cannot continue like that. And we actually, it's also a colleague, Simon Westphal, and we were on the Berlin conference showing that. So we did invest in scaling out the scheduler and making this component also highly available with using Zookeeper and that possibilities. And I can tell you since then we almost had, I don't know, maybe once a year or so, some special update where we have a downtime. Otherwise, we do regular updates like every 2 weeks without any downtime. And we have almost no big outages. Of course, there are, with changes, there are incidents and so on, but we are able to handle that meanwhile quite well. Then another bit smaller thing, so the bubbles also indicate a bit maybe the complexity or effort of changes, was that our projects got bigger and bigger, and it was getting difficult from the UI to get an overview for the ones who operate these CI projects. There we did one thing actually first we created a spec for this, how to improve the status page and make it better for large projects if you have a lot of changes going on and a lot of repositories involved. That's actually a nice way in the Zuul project, the specifications, because there you can, and everyone can review, can put in new ideas and concerns also. So that's, I think, a good way to get also involved, even if you would implement it, but you can take part. And that's actually the result here at the bottom right corner, where you can see, okay, it's much more compact design. You can filter for pipelines now and so on to get a good overview.
So in cloud computing, people are talking a lot about illusion of infinite resources. But at the scale we operate, it's no longer an illusion. From time to time, we hit the capacity limit in the cloud when certain types of instances are requested by the builds. So to minimize this issue, we implemented Fleet API support last year. With Fleet API support, a job can be configured with multiple instances and let the cloud decide which is the best available option to run. It greatly minimizes the risk of insufficient capacity issue. And when it further works together with spot instance, it further reduces the chance of instance reclaim improves both cost efficiency and resilience. We have been working since last year together with Upstream on the node pool in Zuul, aka NITS. NITS is a re-implementation and improvement of node pool. James Player will be giving a talk dedicated on this topic today. So please check the schedule. You may not want to miss that. Last but not least, OIDC support. So as you know, secret handling has been a core feature in Zuul. Secret credentials can be encrypted and stored in repository. However, at a larger scale, it can be challenging. On one hand, static secrets is a security risk. On the other hand, it takes a lot of effort to frequently rotate a large amount of secrets. So we came up with the idea of OIDC workload identity federation. As Thomas mentioned earlier, a specification was created first to collect feedbacks from the community, and it was finalized after several rounds of discussion and review. Then the feature was implemented and released in May this year. With this feature, we introduced a new secret type called token secret to be distinguished from the classical data secret. With token secret, a short-lived token is created dynamically during the build run. So there is no need for secret rotation anymore. I would like to give a little bit more detail about OIDC. This is how it works. When the job is run, the Zuul, specifically Zuul executor, generates OIDC token, and the playbook can use this token to request access token from the service. So the target service here can be, for example, Jira, Artifactory, or even Zuul itself, if you want to authenticate your build to access the Zuul API. Then in step 3 and 4, the service would download the public keys. And in step 5, with these public keys, the service is able to verify that the token is actually issued from the trusted Zuul. And it finally returns the corresponding access token back to the build. The playbook then can use this access token to perform any permitted operations. To use token secret, you first need to configure Zuul as a trusted OIDC identity provider in the target service. This is service specific. You can refer to the documentation of the target service, how to do that. Then you can define OID or a token secret, like a data secret. Just instead of define token attributes, you define OIDC attributes. And you can define several customized attributes here. For example, you can define the valid period of the token by setting the TTL attributes. And you can also add custom claims to the token, for example, the audience. Once defined, you can use it in the job configuration and use the secret variable in the playbook. And the content of the secret variable will be generated dynamically, and you can use it in your job. So for more information, you can refer to the Zuul documentation on secrets. And beyond the major features we have introduced, we have also been contributing a lot smaller changes, smaller features, bug fixes, optimizations, documentations, and etc. So over the past years, we have been There have been more than 1,000 Gerrit changes from BMW has been merged to the Zuul repositories. And together with all the contributors from the community, we are continuously improving Zuul to be more reliable, scalable, and powerful.
Yeah, and that is, reliability is actually one foundation, because if you, as we shared, so if our all the onboard software developers are relying on the CI system, and you can imagine there's a downtime, it's really a big impact. And also, like in the other talk it was mentioned, performance is a feature, so it's also something we need a high performance, and therefore all these small improvements have been really important. So we have been looking where we have bottlenecks and where can we help to improve something. That was one success factor. I think another one was working continuously, really, and having a long-term perspective, so that we had this vision of supplying one CI/CD system as a service, but then also continuously work with the community, with the Zuul community, because there was already open source, there was a really great system, there's a great system, and so we can use that, and we also then like to contribute to that, and I think that was really good. Also like having the possibility with James Blair as a project lead to work closely together. I think that's really very, very great for the success. Another thing I want to emphasize, maybe I don't know if you have similar challenges. So challenge for us is how do we optimize and how do we see the bottlenecks. One thing we did from the beginning was, and that is a stream at the bottom, to have really good logging and metrics, alerting and all that. We actually have an extra system to collect logs and analyze them. That's maybe also something we can contribute more in the future. So we have good performance data, and we supply that to our colleagues who do the software builds, the test builds and so on, so they can actually see also what's happening, where are instabilities, where is performance, maybe bottlenecks. The last 2-3 years we did extend that, because operating at this scale, the costs are really getting important. And so actually we collect also central cost data from the clouds, and we tag them, and we put all this data to a common cloud data hub, we call that, a data lake. And by this we can actually match really the cost data with the technical data. What does it mean? That means that we can drill down for one pull request or Gerrit change, for one job, the actual costs that were there in the infrastructure. So how much did that cost, or also which CI jobs are actually the most contributing most to the costs, or are there any opportunities to right size? So are we wasting some infrastructure resources? And that was now used a lot to optimize for the costs. Yeah, and with that, already looking at the next steps, one thing that we are looking forward is to taking this new node pool in Zuul into use. So what Jim will later today show, because it has really good features, like we can pre-validate new cloud images for the CI builds before they are getting actually active, and many other things, also performance and so on, but that will be shown in details. Then, I have been showing metrics a little bit how we do that, but there's definitely more to do, and we don't want to just throw more infrastructure at software builds and so on. It's costly, so we want to see how can we optimize better, and there's definitely more to do. Also in Zuul itself, like the scheduling, I think these are things where maybe we can do more to improve performance, but not via infrastructure. And yes, UI is always a topic, so maybe also for you, if you have good ideas, I think there's also something we can maybe do more and contribute more. I noticed I did not introduce myself in the beginning, so I do it in the end. I'm Thomas Zink, and I'm responsible for the CI system together with Zhang and other developers, DevOps engineers at BMW. And thank you for your attention.
Thank you. Merci.
And maybe one thing, we are still around, so approach us if you have questions or comments. There's also a project table, I think at 10 past 2, and we'll be there.